Hello students, welcome to this theory session of our topic matter in our surroundings. So we have discussed about latent heat in the previous session. In this session, we'll be discussing about the natural consequences of latent heat of fusion of ice. So let's start our session here. Natural consequences of latent heat of fusion of ice. Now, water has one of the highest latent heat of fusion values of all substances and therefore has several applications. I'm sorry, it's several. What is the latent heat of fusion of ice? It is 3.3 into 10 to the power 5 joule per kg or 80 calorie per gram. Latent heat is what? It is I'll just revise it. Latent heat, it is the amount of heat required to convert unit mass of ice or 1 unit mass of ice to 1 unit mass of water without change in temperature at constant pressure. At atmospheric pressure, at atmospheric pressure. See, in shorthand notation, it can be written as heat required to change what? Say this is the heat supplied. To change what? 1 unit mass of what? Of ice to 1 unit mass of water at what? At its melting point, right? Without change in temperature. And that too under normal pressure. Now there's one example, we have discussed it. Ice cubes are added to cold beverages rather than ice cold water. What is the reason? The latent heat of fusion of water is 3.3 into 10 to the power 5 joule. That is the latent heat of fusion of, That is 3.3 into 10 to the power 5 joule per kg. This is the latent heat of fusion of ice actually. So this is ice. The latent heat of fusion of ice is how much? 3.3 into 10 to the power 5 joule per kg. That is 3.3 into 10 to the power 5 joule of heat is needed or absorbed to melt 1 kg of ice. Now, the heat required to melt the ice comes from the food or drinks in the beverage. As heat leaves the food, it becomes cold. I hope you have understood this. See, this much amount of heat will be released per kg. If you're using 1 cube, it will require that much amount of heat from the liquid. Right? The second one is preventing frost damage. See, where frozen conditions are there, or when there is, say, where frost or the snowfall and all those things occur, say, where the temperature goes below the freezing point. There, how the crops are protected. Now, when 1 kg of water freezes, it releases 3.3 into 10 to the power 5 joule of heat energy. Right? Water is the liquid state. It changes from liquid to solid. Right? So from liquid to solid. Liquid particles far off. And in motion, solid particles settle down. You can just imagine these particles as if the liquid particles are the particles, they are just like you when you have just woken up, had your breakfast and lots of energy. Moving here and there, doing things. Solids, these are the particles, no energy, just settle down, lots of intermolecular force of attraction. So what this liquid does? It releases energy. Right? In order to get frozen. So how much energy it will release? What is the latent heat of fusion of ice? It's 3.3 into 10 to the power 5 joule. That is when 1 kg of ice changes to 1 kg of water. What it does, it absorbs 3.3 into 10 to the power 5 joules of energy or heat. So water will have to release that equal amount. Now farmers use this principle to prevent frost damage to their orchards and other crops. See, these are water sprinklers. Now how they are used. See, if these are the plants, when the conditions are, the temperature is very low and it's freezing, the plants will get damaged. So what the farmers do? When a frost is predicted, that is when the freezing conditions are predicted, farmers turn on the water sprinklers. As water falls on the plants and starts to freeze, heat is released to the surroundings and plants. The heat helps the plants stay warm enough to prevent damage. This only works when the temperature does not drop much below freezing. In short and sweet, I can say that, see this water sprinklers are used. Water will be deposited on the plants, right? Now when there are freezing conditions, what will happen? Whatever water is deposited, it will change into the ice, right? When liquid is changing to solid state, it will release energy. So that energy release prevents the plants from getting freezed. Right? This is one of the very good consequence of high latent heat of fusion of ice. Otherwise, plant will also get frozen and the whole of the orchards and their crops will get destroyed or damaged. So this is one of the consequences, or this is one of the very good reason, or this is one of the very good facts which is being utilized by the farmers. Let's take up another example. Melting of snow in mountains. The snow on mountains does not melt in one go because it needs a lot of energy to melt. Say, how much of energy is required? It is 3.5 into 10 to the power 5 joule per kg. Right? 3.35. The thing is wrong. I'll correct it. So how much of energy is required for melting 1 kg of ice? It is 3.3 into 10 to the power 5 joule per kg. So from where this heat is going, they are going to get this heat? At higher altitudes and high slopes of the mountains, the intensity of heat energy is low. So they can't get this much of energy immediately. So that is why all the snow doesn't melt in just one go. So what will happen if all the snow melts? Then our rivers will get flooded, right? There will be flood. The water level in the river and seas will increase. But it is not happening. Why so? Because the latent heat of fusion of ice is very high. That is 3.3 into 10 to the power 5 joule per kg. So for 1 kg of ice to melt, how much of energy is required? 3.3 into 10 to the power 5 joule per kg. I'm repeating this number so that it gets fixed in your mind. So now that much of heat energy is not available. So all the snow doesn't melt in one go. Now as a result, what happens? As a result, the snow on mountain melts slowly. The slow melting of the snow helps us in two ways. First of all, it prevents flooding of rivers. Secondly, rivers remain full of water round the year. Say if the snow would have got melt, if the snow would have melted in one go, what happened? What would have happened? The rivers would have flooded once and then all the water gone, evaporated. We are left with no water. But what happens? The snow melts slowly, slowly, slowly. So that the rivers are full of water throughout the year. Why snow melts slowly? Because for melting 1 kg of ice, how much of energy is required? 3.3 into 10 to the power 5 joule. So that much of energy is not available at once, so it melts throughout the air slowly, slowly, and slowly. So this is also helping us. Let's take another consequence. There is one more interesting thing related to water, students. High specific heat and latent heat. This is high specific heat capacity and latent heat of water makes the survival of aquatic animals during winters possible. See what happens during during winters in polar regions. What will happen? All the water will convert into ice. So what will happen to the aquatic organisms? It would not be possible for the aquatic organisms to survive. But there are two essential things about water. That is, it has got the high latent heat of fusion and also the high specific heat. Now, what is the specific heat? Specific heat, it is the quantity of heat required to raise the temperature of whole body by 1 Kelvin or 1 degree centigrade. Is what is the specific heat capacity. This is actually high specific heat capacity. So what is the specific heat capacity? It is the amount of heat required to raise the temperature by 1 Kelvin. That is the specific heat capacity. There is specific heat capacity of copper, iron, any of the metal or water or any of the liquid. Now, specific heat capacity of water is much higher than those of all other common substances. Right? Say, the same quantity of heat will rise the temperature of the body more as compared to water. If the same quantity of heat is supplied to water and other things, say I can take your any metal or any other substance. So the temperature rise in the other substance will be more as compared to water. Let's see how it helps the aquatic animal. See what happens. So this is a lake or this is a water body. All the things are frozen out. See, the plants are frozen out. But water, it will freeze slowly. All the water will not freeze in one go. Right? See, if a part of water has been frozen, what will happen? It will just come up. See, if the inside water has been frozen, it will come up. Because the density of ice is less than water. And it will float on the surface of water. Then how the specific heat and latent heat are related to it? Now let's check out. High specific heat of water. What does it mean? It is the amount of heat required to rise the temperature of water by 1 Kelvin or 1 degree centigrade. That is very, very high here. So for cooling that much amount of water, the amount of heat release will be more. Right? Say, specific heat. It is what? It is the amount of heat required to raise the temperature of that whole body by 1 Kelvin. So if it has to freeze, if water has to freeze, so what will happen? The heat energy will be released. Right? Now that is what? That is very high. And secondly, while freezing, the amount of heat energy released is also very high. That is, when 1 kg of ice melts to 1 kg of water, how much of heat energy is absorbed? 3.3 into 10 to the power 5 joule. It means when water is freezed to ice, per kg, how much of energy will be released? 3.3 into 10 to the power 5 joule. So the amount of heat released is very, very high in case of water. Right? So high specific heat of water and high latent heat of freezing makes water to lose heat energy slowly. So this is so high, it will lose it slowly only. Now this makes only the upper layer of water to freeze. What happens if water has frozen? When water has frozen, so ice is formed. That ice has got a lesser density as compared to water. So it moves up and floats. Now, in order for the lower layer of water to get frozen, what will happen? This particular amount of energy should be released. And it is released slowly. Right? The lower layer of water remains in liquid form due to the higher density. Now, this makes the survival of aquatic animals possible during winter. So, whenever that particular, say there is ice is floating above. See what happens if the ice floats above here? Whenever when the ice is formed, it will float on the surface. Because of the low density. Ice has got a low density. I told you why so. Because ice has got a cage-like structure. There is space between the molecules. Whereas water has got a compact structure. Right? Whereas ice has got this cage-like structure. So, ice has got a less density. Now, below this, whenever ice has to be formed, the specific heat has to be released and also the latent heat. Water has got high specific heat capacity. That is, to raise its temperature by 1 Kelvin, large amount of heat is required. So, if we want to just decrease the temperature, that much of heat should be released. And also, for changing water to ice, the latent heat is also very, very high. So as these heat energy release, due to this high specific heat capacity and high latent heat, the lower layer of water stays in the liquid state. And water has got a higher density as compared to ice. So in that water, the aquatic life can survive. I hope I was able to just explain this. If you'll go through the text, it will be more clear to you. In cold places, the weather becomes very cold as soon as snow starts melting. See, and this is because snow absorbs heat equal to its latent heat of fusion from the surroundings. Say when there is a snowfall, the weather is pleasant. Right? Why is it so? When there is snowfall, what is happening? The water vapor in the air is changing to ice. The water is changing to ice. It means it is releasing energy. How much of energy? 3.3 into 10 to the power 5 joule per kg. So that makes the weather pleasant. But when the snow starts melting, or when the ice starts melting, what will happen? It will take up this particular amount of heat from the surrounding and melt. So when it is absorbing heat from the surrounding, what will happen? The temperature of the surrounding will get lowered. So that is why in cold places, weather becomes very cold as soon as snow starts melting. Icebergs can be carried by ocean currents over long distances without melting due to the high latent heat of fusion of ice. It becomes very cold after hailstorm. This is one of the consequences of high latent heat of fusion of ice. That's why it becomes cold after hailstorm. What is a hailstorm? It is a thunderstorm which produces hail. And what is hail? Hail is the lump of ice, which is just like a ball or irregular lump of ice. Right? And that irregular lump of ice, each of them is referred to as ice or hail. That is, each of them is referred to as hailstone. Say these are called as hailstone. These are what? Irregular lump of ice. Now this is formed with thunder and lightning, and it reaches the ground. Right? Now as soon as these ice lumps have reached ground, what will happen? These ice lumps will melt. Right? Now while melting, what they'll do? They'll absorb energy from the surroundings. And when they'll absorb energy from the surroundings, what will happen? The weather will become more cold. Right? So hailstorm is nothing but a thunderstorm which produces hail. What are hail? Hail is an irregular lump of ice, the individual of which is called as hailstone. And these reach the ground. When this hail are formed in very high, higher altitudes, they'll reach in a very, very small form. Right? So after the hailstorm, what happens? The weather becomes very cold. Okay, because whatever hail is formed, that gets melted, or that melts. How it melts? By absorbing energy from the surroundings, and thus lowering the temperature. So these are all the natural consequences of high latent heat of fusion of ice. I hope you have understood this and also enjoyed this session. Now I'll be concluding this session, students. In the next session, we'll be discussing about the latent heat of evaporation. Thank you, students, for listening patiently, and just go through the text. I every time say that, listen the session and then go through the text, so that you're through with the concepts. Thank you once again, and do have a nice time ahead.